So picture two identical pots sitting side by side in a garden, like literally right next to each other.
Right, sharing the exact same microenvironment.
Exactly. I mean, they have the exact same soil temperature, the same ambient humidity, the same arc of afternoon sun, and, the exact same exposure to the local insect population.
Which is usually the deciding factor for garden plants, yeah.
Yeah. But if you look closer at the plants inside these two pots, you see two completely different realities.
Night and day.
Literally. So in the pot on the left, you have a regular basil plant that is just being systematically dismantled. I mean, leaves chewed to lace, stems sagging. It is an absolute buffet for garden pests.
And total loss.
But then in the pot on the right, separated by just like mere inches of air, sits a holy basil plant.
Right, ocimum-tenuiflorum.
Yes. And it's completely impossibly untouched.
It really is the ultimate natural control group. I mean, what you are describing is basically a perfect real-world laboratory. And, well, it's the centerpiece of the field notes we're examining today.
Welcome to today's deep dive. We are super thrilled to have you with us. Our mission today is to figure out the invisible mechanics behind that very stark contrast.
Because it's not just luck.
No, not at all. We are analyzing a dispatch from a very dedicated, very meticulous gardener named Ang. And just to give you a sense of the caliber of our source today, this entry, which was published today, August 4th, 2026, is actually titled Notes on Gardening, Part 976.
Part 976. I mean, when you see a number like that, it signals a major shift.
Right. That is serious dedication.
It really is. It's a shift from casual hobbyist to, like, an empirical observer. Someone on their 976 documented dispatch is basically practicing the scientific method right in their backyard.
Yeah, they're not just watering plants, they're studying them.
Exactly. They are tracking the subtle, compounding variables of a microecosystem over a long period of time.
And what Ang has documented here is this fascinating mystery of survival. The scientific name for the thriving plant, as you mentioned, is ocimum-tenuiflorum, or holy basil.
Yeah, holy basil.
And it is sitting in this microscopic war zone, yet it remains completely pristine while its neighbor is just devoured. Okay, let's unpack this because, it feels like one of those infomercials.
Oh, like the side-by-side product comparisons?
Yeah, like, it's already basil getting eaten. It's just wild how two plants sitting right next to each other can have such vastly different fates when facing the exact same pest threat.
It is wild, yeah.
So I have to ask, what exactly is acting as the holy basil's invisible shield? How does a plant that's, literally rooted to one spot fight off a whole swarm?
Well, what's fascinating here is that to understand that, we actually have to look past the visible leaves and stems. We have to examine the plant's volatile chemistry.
Chemistry.
Yeah. Nature has equipped holy basil with a highly sophisticated, multi-layered defense system.
Which regular basil apparently missed out on.
Unfortunately for the regular basil, yes. Ang's notes highlight that holy basil contains significantly higher concentrations of specific natural compounds. We're talking about camphor, rosmarinic-acid, and most notably, eugenol.
Okay, those sound like ingredients you'd find on the back of, like, a really expensive skincare bottle. Not necessarily something growing in the dirt.
Right, they do sound very clinical.
But Ang's notes specifically flag these compounds as natural deterrents, right? Like they're acting as an actual insect repellent.
They are, yeah. But they are doing so much more than just sitting passively inside the plant's cellular structure. These are what we call volatile organic compounds.
Volatile meaning they react.
Well, in this context, that word volatile means they easily vaporize at room temperature.
Oh, I see.
So the holy basil is actively off-gassing these chemicals. It's basically creating an invisible protective cloud, like a microatmosphere of deterrents immediately surrounding its leaves.
Wow. And Ang's notes zero in on one of those chemicals in particular, eugenol.
Yes, eugenol is a huge player here.
The text states that eugenol is responsible for giving holy basil its intense, clove-like kind of peppery aroma. But I have to pause here, because this feels like a total paradox to me.
How so?
Well, wait, so the exact same thing that makes this plant smell delicious to humans, that rich, spicy profile that acts like a chemical bouncer keeping bugs out of a club.
That's a great way to put it, actually.
It's just funny that the flavor profile is the defense mechanism.
It is. But consider how an insect actually navigates its world. Pests don't just, wander aimlessly. They are guided by highly sensitive olfactory receptors.
Right, they're sniffing around for food.
Exactly. They're designed to sniff out the very faint, sweet scent of tender, vulnerable plant tissue. So when an insect flies into the airspace of the regular basil, It gets a clear, inviting signal. Soft food right here.
Like a neon diner sign.
Exactly. But when it drifts over to the holy basil,
It hits a bouncer.
it hits a literal wall of eugenol and camphor. To the pest's receptors, that intense peppery cloud isn't appetizing at all. It is absolute sensory overload.
So it just overwhelms them.
Completely. It scrambles their navigation. And on top of that, compounds like camphor are mildly toxic to many small insects. So the bouncer isn't just standing at the door. The bouncer is deploying a chemical deterrent that overwhelms the pest's nervous system. Pest resistance isn't just about being tough. It's about complex biochemistry.
That is incredible. These compounds are working in concert as a natural repellent, which completely explains why the bugs in Ang's garden opted for the regular basil instead.
Path of least resistance.
But wait, if this chemical shield is so incredibly effective, why do we even bother growing regular basil?
That's a very fair question.
I mean, it seems like a massive evolutionary failure by comparison. Why hasn't regular basil evolved to just, pump out eugenol and save itself the grief of being eaten alive?
What comes down to the brutal economics of plant evolution?
Economics.
Yeah, every living thing has a finite energy budget. Synthesizing complex volatile organic compounds like eugenol and rosmarinic-acid, it requires a massive caloric and metabolic investment from the plant.
So it's highly expensive to manufacture the chemical weapons.
Incredibly expensive. Regular basil has essentially opted for a different survival strategy, which is rapid vegetative growth.
Ah.
It invests almost all its energy into growing leaves fast and reproducing quickly. It plays a numbers game. Grow faster than the bugs can eat you.
And holy basil takes a different path.
Exactly. Holy basil, ocimum-tenuiflorum, takes the opposite approach. It grows a bit slower, but it heavily funds its defense budget. It sacrifices rapid expansion to maintain a standing chemical army.
That makes total sense. One strategy is like live fast, die young, and hope you drop some seeds first.
Right.
And the other is build a fortress and hold the line. But I want to transition here because chemical warfare is really only half the story.
Yes, it is.
Let's test the limits of that fortress. Because an invisible cloud of peppery scent is great, but I don't know, a strong afternoon breeze could blow that vapor away, right?
Absolutely. The chemical cloud isn't foolproof.
Or you might get a particularly desperate, starving aphid that decides to just push past the sensory overload anyway.
Hunger makes bugs bold.
Right. So if the chemical bouncer gets bypassed, what happens when the bug actually lands on a leaf? If the invisible shield fails, the plant has a visible, physical backup plan.
It does. And that is where Ang's 976th observation gets truly fascinating. The text points out that holy basil doesn't just rely on its chemical aroma. It has a robust physical defense.
Right, the actual architecture of the plant.
Yes, Ang documents that it features woodier stems, thicker stems, and a much more rugged growth habit.
Here's where it gets really interesting. Rugged. I love that description for her.
Very evocative, isn't it?
Yeah, because if you think about the regular basil we buy at the grocery store,
Yeah.
the stuff sitting in those little plastic clamshells, it is incredibly fragile.
Very delicate, tender leaves.
Right, it's like a delicate salad green.
Yeah.
The stems are fleshy, practically translucent, and they bruise if you even squeeze them too hard.
Pests can easily munch right through that.
Exactly. But Ang is describing holy basil as armored. So it's not just smelling bad to bugs, it's physically harder for them to eat, like trying to chew on a woody twig.
If we connect this to the bigger picture, we are looking at a shift from chemical warfare to mechanical defense. To understand why this stops pests, you have to look at the actual mechanics of an insect's mouth.
Okay, getting microscopic again.
Right. The mandibles of typical garden pests are perfectly adapted to pierce and chew soft parenchyma cells.
That tender, water-filled tissue.
Yes, the stuff that makes up a regular basil leaf.
Like drinking from a juice box.
A very apt way to visualize it.
Huh.
But when that same insect tries to bite into the rugged, woody stem of a holy basil plant, it encounters a material problem. Woodiness in plants comes from a complex polymer called lignin.
Lignin, okay.
And lignin is dense, it's tough, and it's highly resistant to mechanical breakdown.
So the bugs literally lack the jaw strength to chew through it. Like it's a literal barrier.
Their mouthparts can actually sustain damage trying to penetrate it, and even if they manage to scrape some off, lignin is notoriously difficult for insects to digest.
So it's not even good food once they get it.
Exactly. It throws off the insect's energy calculus. A foraging pest is trying to gain calories, right? If it has to expend more energy trying to saw through a woody stem than it gets back in nutrition, it will just abandon the effort.
The juice just isn't worth the squeeze.
Literally. The plant has made itself mechanically unprofitable to eat. And this dual-layered approach, the chemical repellents combined with physical resilience, is what truly defines the hardiness of the ocimum-tenuiflorum compared to its delicate neighbor.
Which explains entirely why the regular basil in the pot next door is taking the absolute brunt of the attack.
It's the easy target.
It has neither the chemical weapons nor the physical armor, making it the path of least resistance. But, survival is really only step one in nature, right?
Definitely. Step 2 is always reproduction.
And this brings us to the final phase of Eng's dispatch, because we're transitioning from understanding why the plant survives to what the gardener is actually doing with this thriving, resilient crop.
Right, because this isn't just a diary.
No, it's a working cultivation log. Eng notes that because this holy basil is doing so incredibly well, there's now this abundance of seedlings and plants ready for the next phase.
The plant defended itself, and now it's propagating. And Eng has to make a crucial decision about how to foster that next generation.
Right, so Eng mentions getting ready to transplant these new seedlings into their own individual pots. But there is a very specific, deliberate detail included here that we need to talk about. The notes specify using a, quote, more sandy potting mix for these transplants.
That detail about sand might seem minor, but it's actually the most important horticultural insight in the whole dispatch.
Really? Just the sand?
Yes, because it bridges the gap between observing a plant's physical traits and actively supporting its biology.
Well, I mean, the seedlings are graduating, right? They're moving out of the crowded nursery into their own private sandy beach apartments.
That's one way to picture it, yeah.
So what does this all mean for the listener? I mean, sandy soil drains water much faster than typical potting clay. Why is that drainage specifically critical for a rugged plant like holy basil?
Well, think back to the physical fortress we just discussed. Plants that evolve woody, rugged structures are typically adapted to environments where water moves quickly through the soil.
Okay.
They are not marsh plants. So if you take a plant like holy basil and stick it in heavy, waterlogged soil, you suffocate the root system.
And waterlogged roots lead to root rot.
Which is catastrophic, because root rot bypasses all of the plant's above-ground defenses. If the roots begin to rot, the plant's vascular system basically collapses.
Oh, I see.
It can no longer transport water and nutrients up into the leaves.
Wait, if it can't pull up water and nutrients, it loses the raw materials it needs to synthesize the eugenol and the camphor.
Exactly. The chemical supply lines are cut, the invisible shield drops.
Wow. And without the water pressure to maintain cellular structure, even those rugged stems start to weaken. So the entire fortress basically collapses from the inside out just because the soil held too much water.
You've hit on the exact mechanism. This highlights the real value of Eng's hands-on learning. Eng observed the woody, rugged nature of the holy basil and deduced its environmental needs.
Adapting to what the plant actually wants.
Right. By providing a sandy, fast-draining potting mix, Eng ensures the root system remains highly oxygenated. And that healthy root system fuels the energy-intensive production of all those defenses above ground. It's the practical application of horticultural observation.
It is such a brilliant, holistic approach. You can't just treat every green thing in your garden the exact same way. You really have to read the architecture of the plant and adapt your terrain to match it.
It challenges the assumption that plants are just passive scenery.
It totally does. Which is a great way to summarize our key takeaways for you, the listener. We started with this mystery of two side-by-side pots. And what we found is that holy basil's superiority in pest resistance isn't luck at all.
Not even a little bit.
It comes down to a really potent mix of natural chemical deterrents. The eugenol, camphor, rosmarinic-acid, plus those rugged, woody physical traits. And all of that leads to a highly successful propagation.
It is a perfect synthesis of natural adaptation and human observation, which actually raises a broader, somewhat philosophical question regarding the source text.
Oh, okay. I love a good curveball. Lay it on me.
Well, consider the end product of all this conflict. We know from the notes that ocimum-tenuiflorum relies heavily on these intense chemical compounds, specifically eugenol, to fight off pests.
Right. The peppery, clove-like aroma is literally a weapon of war.
Precisely. It's deployed under the constant stress of potential predation. But what do humans value most about holy basil?
Well, the smell and the taste.
Exactly. We prize that exact aroma. We harvest it, we extract it, we cook with it, we steep it in our teas because we find that complex, spicy flavor profile so deeply satisfying.
Wait, are you saying, like, our favorite flavors are just stress responses?
It forces us to ask, are the very flavors and aromas we prize in our culinary herbs the direct, unavoidable result of the plant's evolutionary struggle.
Oh, wow.
If a plant never faced a harsh world, if it didn't have to defend itself against a swarm of pests, if it just grew effortlessly in a perfectly safe bubble, would it even taste as good?
That is, wow.
Yeah.
If it didn't have to fight, it wouldn't need the eugenol. It would just taste like bland, watery leaves.
Yeah.
The flavor literally is the fight.
The adversity is the source of the value.
That completely changes how I will view the spice rack in my kitchen. I mean, you look at a garden, you want to project this idea of a peaceful, harmonious sanctuary.
But it's a battlefield.
Yeah. The reality is that the vibrant smells, the intense spices, the resilient stems, they are the products of peace. They are the beautiful, delicious byproducts of a relentless, microscopic war zone.
Survival of the fittest, rendered in scent and flavor.
Absolutely incredible. Well, thank you all for joining us on this deep dive into Ang's garden notes. We hope the next time you walk past a revy little plant or, catch the scent of peppery basil, you appreciate the invisible battles being fought just to bring that flavor into the world. Keep observing, keep questioning the world around you, and we will catch you on the next deep dive.